us discuss about insulation coordination. Okay, so we know in the power system, okay, in the power system, so power system can be categorized into three main categories, that is generating system, transmission system, and distribution system. So whatever power is generated, that power is stepped up, then it is transmitted, then it is stepped down at the load centers, and it is distributed to different sectors of load. So the faults can occur, okay, in the generating station equipments or during transmission and in the distribution sectors also. Okay, so proper insulation must be given to each and every equipment. Okay, so of course protective devices will be there, but primary for primary safety, okay, so proper insulation must be given to the electrical goods of the power system. Okay, so the equipments in the power system are provided with proper insulation based on the rating, as well as in the power system, in order to protect the electrical equipments of the power system, whatever protective devices that are used, such as lightning arresters or surge absorbers or circuit breakers or the relays. Okay, so these are all the protective devices, switchgear. Okay, you know what is meant by switchgear. In the introduction, I have explained about it. So all the switchgear equipments also require insulation. Okay, of course they are protective devices. They, if fault occurs, they will definitely do their means whatever operation that they have to perform, they will definitely perform that operation. They will definitely disconnect the unhealthy section from the healthy section in order to protect it from fault. Okay, but they too require proper insulation. Okay, because if over voltage occur in the system, okay, even the protective devices may also get damaged. Okay, not only the electrical equipments during faults, even the protective devices may also get damaged. So insulation is required for both the protective devices as well as for the equipments of the power system. So if you see in this image, you can see a power station here. Okay, if you carefully observe, it is a hydral power station. If you are able to identify what is this. Okay, it's a, there is a dam here from where water is flowing. Of course it is not our subject, but so here, this is the generating station, okay, and you can see some switches here. If you carefully look into this image, you can see some switches, okay. So, and this is the transformer symbol, okay. This is a step-up transformer. You can even see the rating of the transformer here, 11 kV by 275 kV, okay. And you can see this is current CT breaker. Okay, so there is a circuit breaker here. Okay, so if you see in the bottom of left side bottom, the red color boxes are the transmission line protection relay devices, and this blue color boxes are transformer protection relay devices, and the green color are the fault locators. Okay, so the switch symbols are the circuit breakers. Okay, so this whole power system, the power is generated here, then it is transmitted, and in between, okay, uh, okay, it is transmitted, and wherever load centers are there, it is distributed. Okay, at the load centers it is distributed, and you can see the protective devices throughout the system in this diagram. Okay, in this image you can see protective devices are there. So insulation is required to protect not only the power system equipments, it is also required for the protective devices. Now So there should be proper coordination between the insulation levels of the protective devices as well as the insulation level of the equipments which are to be protected by these protective devices. Okay, so that coordination or correlation between the insulation levels of the protective devices as well as the equipments which are to be protected by these protective devices is known as insulation coordination. Okay, I hope you are able to understand. Okay, once again I will repeat. The insulation coordination means it is a correlation of the insulation of various equipments in the power system with the insulation levels of the protective devices. Okay, so in the power system, different equipments will be there of different voltage ratings. Okay, so depending on their voltage rating, they will have depending on their voltage rating, the insulation level will vary. Okay, for each and every equipment will not be provided with same insulation level. Insulation level will vary from for each and every equipment. So depending on their rating, the insulation levels for the equipments will vary, and based on the insulation level that has been provided to each and every equipment, if fault occurs, they will have their own withstand level for that fault. Okay, so if a fault small, if the rating of the equipment is very, if the insulation level is very high, if any small very small leakage is there, okay, where if suppose LG fault or LL fault occurs, there is any small leakage is there, then the insulation level provided to the equipment will be able to withstand that leakage. Okay, so the protective device will have its own withstand level, okay, for the faults that occur in the system, okay, depending on the insulation provided to it, and the electrical equipments in the power system will have their own withstand level against the over voltages in the power system. Okay, so the withstand level of the equipments to overcome the over voltages, I hope you are able to understand what's meant by withstand level. Withstand level means no damage will occur. Okay, the normal operation of the equipments will continue. Okay, the purpose of the protective devices is to make sure fault current doesn't flow into the equipment nearby whichever equipment they have been connected. The purpose of the equipment is, if it is a step-up transformer, it has its purpose is to step up the voltage level. Okay, if it is a step-down transformer, its purpose is to step down the voltage level. If it is a generator, then its purpose is to generate the voltage. If it is a motor, then it must give out the mechanical energy for the given electrical energy. Okay, so depending on the type of the device and the machine, the operations are varying, and each and every equipment is provided with proper insulation. Depending on its rating, the insulation levels will vary, and each equipment will have its own withstand level against the over voltages. Okay, so it means whatever insulation is provided, it will be able to, it will be primarily protecting the equipment from the fault. Okay, if that insulation fails to protect, then these protective devices, okay, they will try to protect the equipments. Of course, as the protective device will not wait till the insulation breakdown occurs in the equipment. Okay, the protective device will not, that's not the process. I will tell you how the equipments are protected against the faults in this concept itself. I will tell you it, where you will get the proper clarity if you are listening carefully to the class instead of sleeping. Okay, so the withstand level of the voltage means over voltage. Okay, so withstand level of the over voltage of different equipments will be different. Okay, it will vary depending on their ratings. Okay, and different protective devices are there. Okay, there are very different protective devices. What are all the different protective devices we will discuss in the next unit. Okay, to protect each and every equipment against over voltage. Okay, so the insulation of protective devices must have proper coordination with the insulation of the equipment. Okay, so In power system, suitable coordination of the strength of the insulation of line, transmission line, switchgear, transformers, machines, and the characteristics of the protective devices like rod gaps, lighting resistor, etc. is made. Okay, how it is made, I will tell you. How the coordination is made, I will tell you. Okay, now, so if you observe this curve, okay, if you observe this graph, this is the peak voltage. Peak voltage means it is the over voltage. Okay, this is the over voltage, and with respect to time, how over voltage is varying, you can see here in this graph. Okay, so you can see A and B terms here. A represents the voltage level, the insulation withstand level of the protective device. A represents the curve A represents insulation withstand level up to what voltage the insulation of the protective device can withstand. Okay, means insulation breakdown will not occur up to so and so voltage. Here scale is not there, x-axis, y-axis scale is not there. If it might have been, you will get some idea, but it is not required. Why? Because the devices will be of different ratings. Okay, so I can't take one specific value and I can't tell you in that way. It will be wrong. Okay, now the curve B shows the insulation withstand level of the equipment which is to be protected. A curve A represents the insulation withstand level, means up to what voltage the protective device can withstand the over voltage, means up to so and so voltage. Okay, up to so and so voltage on the y-axis. Okay, the insulation breakdown will not occur for the protective device. But if you see for curve B, up to so and so voltage, this voltage is higher than this voltage. Okay, the peak voltage of this protective device, when you compare the peak voltage of the protective device with the peak voltage of this equipment which is to be protected by the protective device, is more. Means the insulation withstand level, means the over voltage withstand level. Okay, the over voltage withstand level of the insulation of the equipment which is to be protected is higher than the over voltage withstand level of the insulation of the protective device. Means if suppose over voltage occurs of suppose 500 volts over voltage that has occurred in the system is around 500 volts, just for example I am telling you. Okay, and if the insulation withstand level of this equipment is, this equipment means what is it? This is the equipment which is to be protected. Okay, so insulation withstand level is only 400 volts. Okay, then definitely the insulation breakdown will occur because of the over voltage which is 500 volts. Okay, and insulation withstand level voltage of the protective device is less than this equipment withstand level, means it will be definitely less than 400. It may, let us assume it is 350 or 300 volts. So when over voltage occurs in the system, then the insulation breakdown will occur to the protective device. Okay, not in the equipment which is to be protected. So which is the purpose of the protective device is what? If faults occur, it should stand in front of the equipment and it should fight with that fault. Okay, in general words I am telling. Okay, so the purpose of the lightning, whatever protective devices that we are using is to protect the equipment from the faults. Okay, so always the insulation level of the protective device will be less than the insulation level of the equipment which is to be protected. So if fault occurs, if any over voltage occurs, first the insulation breakdown in the protective device will occur. Okay, so that the equipment is not primarily damaged, the protective device will be damaged initially. So okay, so in the power system, the engineers will not manufacture the protective devices and the in such a way that if over voltage occurs, the protective device will not get damaged, because they will start performing their operation. But I am talking in terms of insulation. Okay, so if the protective device fails to do its operation because of, if the rating of the protective device is very low and if the over voltage is very high, then, and if the protective device is unable to protect the equipment from the over voltage, then first the protective device will get damaged. Okay, its insulation breakdown will occur. Meanwhile, the engineers will be continuously monitoring the operation of the system. Meanwhile, they will be, at least if they automatically, if the fault is not interrupted, then the engineers will manually disconnect the healthy equipment from that section wherever the protective device has it has got damaged. Okay, so that's the thing. Okay, so in the insulation means if the protective device is unable to do its operation, if it fails to operate, then first insulation breakdown of the protective device will occur. Later the insulation breakdown of the equipment will occur. Meanwhile, manually the engineers will disconnect the protective device from that equipment which is to be protected. Okay, I hope you are able to understand. Okay, so this shows the insulation characteristics, okay, of the equipment which is to be protected and the protective device. Okay, so you can see the characteristics of the equipment is shown by curve B. Equipment characteristics. Curve A shows the characteristics of the protective device. Okay, so the insulation characteristics of the equipment is much higher than that of the protective device. Okay, so whenever over voltage occurs, the spark over will take first in the lightning arrestor. Okay, if it is a lightning arrestor, if it is a lightning arrestor, it's very good. You people are joining very lately. You people definitely have connectivity issue. It's very good. You keep it up. Okay. Keep it up. You be like that only. You don't improve yourself. Okay. If I have interest, I will definitely join on in time. If I have connectivity issue, I won't be able to connect to the class at all, even at the last moment. I think so, in my point of view. Okay, I thought today I won't be able to take the class. Why? Because power cut. There was power cut till 2:20. Okay, at 2:20 power was reconnected. Okay, let us see the steps to study insulation coordination. The selection of the insulation suitable insulation, which is a function of reference glass voltage. Okay, so first, based on the rating of the equipment. Okay, insulation of the protective device and the insulation of the equipment which is to be protected must be decided. Okay, so initially the reference class voltage will be, means what, we must have some reference. Okay, so based on that reference we will decide the voltage insulation level of the equipments of the protective device as well as of the equipment which is to be protected. So the reference voltage will be always equal to 1.05 into operating voltage of the system. Okay, so it is based on the study. Okay, based on the study and based on the faults that in general they will be occurring now and then. Okay, so based on the analysis, engineers have they have framed this formula. Okay, engineers have framed this formula based on the analysis. So the design of various equipment such that the breakdown voltage or flashover strength of all the insulation in the station equals or exceeds the selected level. Okay, so once the reference voltage is decided, okay, once the reference voltage is decided, then based on the insulation level must be always greater than the reference voltage value. Okay, so it is made sure that whatever insulation level that we are going to provide, it is always greater than the reference voltage value. So how the reference voltage value is decided? It is decided by multiplying 1.05 into the operating voltage of the system, means whatever system voltage is there. Okay, so selection of the protective device will give the apparatus as good protection as can be justified economically. Okay, so means based on the rating of the equipment, based on the reference voltage, based on the insulation level provided to the equipment, later on which type of protective device must be used to protect the equipment must be selected. Okay, so the steps for insulation coordination are: first step is we must decide the reference voltage depending on the system voltage, and later on we must decide the insulation level for the equipment which is to be protected. After deciding insulation level, after deciding the reference voltage, we must decide what should be, which protective device must be connected to it, what should be the insulation level of that protective device. Okay, so these are the steps for insulation coordination. Okay, so let us see the choice of insulation levels for substation equipment. Okay, so this call is being recorded and you people join very lately. I am unable to understand. It's a disturbance to me. Okay, so not for you, but it's really disturbing when students join very lately. Okay, if it was a manual class, it might have been better. Okay, choice of insulation levels for substation. So basic insulation level, the value of the voltage the insulation of the equipment can withstand without being damaged is known as basic insulation level of the equipment. Okay, so basic insulation level of the equipment is the value of the voltage the insulation of the equipment can withstand without being damaged. Okay, so after manufacturing an equipment, proper insulation is given based on the rating of the equipment and based on the reference voltage. Okay, and this insulation, whatever is given, if over voltage occurs, it must not get damaged. Okay, so that is the withstand level. Okay, so the value of the voltage the insulation voltage means the value of the voltage means it is the value of the over voltage, okay, which the insulation of the equipment can withstand without being get damaged. So if over voltage occurs in the system, okay, and if proper insulation is provided to the equipment in which over voltage has occurred, then that insulation, if that insulation breakdown does not occur, then that is known as basic insulation level of the equipment. Okay, the basic insulation level includes some characteristics of the equipment, that is power frequency, voltage withstand level, lightning impulse voltage withstand level, okay, and switching impulse voltage withstand level. Okay, so power frequency voltage withstand level means yesterday I have already discussed all these three terms actually. So power frequency means what? Not at normal frequency when the system is subjected with power system equipments are subjected with continuous supply voltage. Okay, there should not be any leakage. Okay, if proper insulation is given, there will not be any leakage. Okay, so and under normal operating condition due to switching operation and all, if over voltage occur, okay, at normal frequency only, okay, so then also the insulation should withstand the voltage, okay, over voltage, okay, and due to switching operation, okay, if over voltage occur, then also the insulation must be able to withstand the over voltage, means insulation breakdown should not occur. Due to lightning, if over voltage occur, then also the insulation of the equipment should withstand that over voltage. Of course, it's not at all possible to withstand the over voltage due to lightning by the insulation that is provided. We definitely need robust protective devices such as relays and circuit breakers. Okay, to protect the equipment. The insulation cannot protect the equipment from the over voltages that are caused due to lightning. Okay, if you see a single line diagram here, this shows the line diagram of a substation. Okay, so it includes a circuit breaker, a transformer, you can see CB circuit breaker, transformer, isolator, busbar insulators, and line insulators are there. Okay, so even you can see a lighting resistor here. Okay, so all these require, okay, even this transmission line and these protective devices, they require proper insulation. Okay, and there should be proper coordination between the insulation, means the protective device insulation should be less than the line in which they have been connected, or line insulation. Of course, transmission lines, line insulation means insulation is not provided on the line, the transmission lines are placed on the insulators. Okay, so the insulators ratings will vary. Okay, so if you see here in this graph, this is the over voltage and this is the time. Okay, so that what is the peak voltage for? Okay, so the peak voltage, which means that whatever insulation is given to a bus bar, for example, the insulation level of the bus bar will be very high. Okay, insulation level of the bus bars will be very high because they are open to the atmosphere. Okay, the chances of occurrence of fault is more in the outer areas. Okay, in the external areas. Okay, so next one is line insulation, transmission line insulation. Okay, so of course insulation is not directly given to the line, but they are placed on the insulated poles. Okay, and insulators will be at the means at the ends of the line. Proper insulation is provided at the ends of the line at the poles. Okay, so insulation of the transmission line is less than busbar insulation, but it is greater than the transformer insulation and lightning arrestor insulation. Okay, and transformer insulation will be a bit less when compared to the line insulation, transmission line insulation and busbar insulation. Why? Because it is it is provided with, of course, protective devices will be there, but it is placed within a proper enclosure, isn't it? So the insulation level required when compared to line and bus bar is less. And lightning arrestor, of course, LA is the lightning arrestor. Lightning arrestor, since it is a protective device, definitely its insulation level when compared to transformer, line, and bus bar should be less. So this graph shows the insulation levels of different equipments in the power system. Okay, so if you see the insulation level in terms of voltages are given here. Okay, so lightning arrestor insulation level is only around 5000, I'm sorry, 525 kilovolts, whereas transformer insulation level is 700 kilovolts, and the line insulator insulation level is 890 kilovolts. Circuit breaker insulator, of course, here I have not shown any circuit breaker in this. Okay, so I can draw one more line and I can mention that. Okay, so circuit breaker insulation line is 1090 kilovolts and bus bar insulation level is 1180 kilovolts. Okay, so insulation level is gradually increasing as we move from lightning arrestor to transformer to line to circuit breaker to bus bars. Okay, so here, if fault occurs, if over voltage occurs, okay, so whose insulation will, in which device insulation breakdown will occur? According to me, whichever has least voltage level, okay, in that insulation breakdown will occur. So remaining will be safe. Okay, so initially insulation breakdown will occur in the lightning arrestor. Why? Because its voltage rating is very less. Okay, if over voltage occurs, first insulation breakdown will occur in the lightning arrestor. Okay, for you people the slide has changed. Okay, so whenever surge wave comes, the breakdown of the lightning arrestor will occur at 525 kilovolts and all the other equipments are safe. Okay, so you can see the peak voltages here. Okay, you can see the scale here in this. Okay, so this is the transmission line wooden pole. Okay, so impulse would withstand level of the wooden pole. So it is with respect to the transmission line. Next it is with respect to the transformer. Okay, so transformer impulse withstand level. Okay, and next here it is lightning arrestor. Okay, so here spark gap, you can see in between spark gaps are nothing but lightning arrestors only. Okay, or you can, or I can say spark gas will be in lightning arrestor as well as in the circuit breakers. So below this transmission line, I can say it can even be a circuit breaker. We can't say because here specifically it is not mentioned. Okay, if it is mentioned, we can exactly say what is the equipment here. Okay, so in general, if we discuss about, this is the transmission line and this is the transformer and this is the lightning arrestor. Okay, so in terms of voltages, if you see the lightning arrestor breakdown voltage is approximately 400 volts, 400 kilovolts here. Okay, lightning arrestor breakdown voltage is 400 kilovolts here. Similarly, if I say transformer, its breakdown voltage is approximately 550 kilovolts here. Okay, according to this diagram. Okay, according to this graph. Okay, so when insulation breakdown occurs in the equipment which has least insulation breakdown voltage, then all the other equipments are safe. Okay, so you may have a doubt that insulation breakdown voltage of lightning arrestor is 525 kilovolts, but according to this graph, it is 400. Okay, so this graph I have selected from somewhere else, and I have written this content here to understand the concept. I can write here 400 kilovolts. It doesn't matter. Okay, I can write 400, then it will tally with the graph. Okay, so now to understand the concept, we are taking some examples. That's all. Okay, next, volt time curve. Okay, so volt time curve, it is with respect to the insulation coordination. Okay, okay, so now if insulation breakdown occurs, okay, in the protective device, okay, in the protective device, if insulation breakdown occurs, just for example, let us consider a lightning arrestor. So in general, just for example, let us consider a rod gap lighting arrestor, just for example. Okay, if I have taken a rod gap lighting arrestor, in that rod gap lighting arrestor, there will be two rods bent at 90-degree angle. Okay, there will be a gap between the rods. Okay, so those two rods are nothing but we can say electrodes. One rod is connected to the line which is to be protected, another rod is earthed. If you remember, if you are listening carefully to my classes regularly, you can recall that. Okay, so there will be a gap between those two rods. If in the line, if overvoltage occurs due to lightning, for example, okay, then the spark gap, an arc will be struck uh, between those two rods. Okay, so between those two rods, an arc will be struck. Okay, so if an arc is struck, okay, if an arc is struck between the rods, means initially when normal voltage was there in the line that is to be protected, in the gap between those two rods, there was no current flow, there was no leakage current. Okay, but as soon as more voltage has occurred, an arc is struck, there is leakage of fault current flow from the above rod to the below rod. Okay, so insulation breakdown has occurred. Okay, so we will call it as a flashover has occurred across the gap. Okay, so and we can even measure the flashover voltage across the gap of those two rods. Okay, so if insulation breakdown occurs, voltage breakdown occurs, we can say. Okay, if voltage breakdown occurs at certain for a particular insulation of the flashover voltage for a gap, function of both the magnitude of voltage, sorry. Okay, so if insulation breakdown occurs across the gap, okay, then the flashover voltage can be represented by a curve. Okay, the flashover voltage which appears across the gap can be represented by a curve known as volt time curve. Okay, so the voltage breakdown has occurred across the gap between those two rods. Okay, so this voltage breakdown can be represented by the magnitude of voltage and time. Okay, for by both magnitude of voltage with respect to the time. Okay, that is known as volt time curve. I hope you have understood. I don't know whether you have followed or not. If you want me to repeat, I will repeat this. What is meant by volt time curve? Okay, if you want me to repeat, type R. Okay, so whenever if over voltage occurs in the system, if insulation breakdown occurs, then okay, if insulation breakdown occurs, then that breakdown voltage across the gaps of the rods can be represented on a graph by in terms of magnitude of voltage and time. Okay, so the volt time curve is a graph. It shows the relation between the flashover voltage. Crest flashover means peak flashover voltage. Peak flashover voltage means, you know, the impulse waveform. You know the impulse waveform, it will be somewhat like this. Okay, it will be somewhat like this, or do I have any? No, I don't have any other diagram here. So it will be somewhat like this. So I have already told you the peak is the one which causes more damage. Okay, so as sharp as the peak is, more damage will occur in the system. Okay, to the equipments of the power system. Okay, so this volt time curve is a graph. It shows the relation between the flashover voltage, so means the peak of the over voltage, and the time at which the flashover has occurred. Okay, so it shows the flashover relation between the flashover voltage and the time at which the flashover has occurred. Okay, so let us see the procedure for constructing this volt time curve. Okay, I think I will continue this procedure and next content in the next class, because if I continue, I won't be able to complete this procedure, and your next class will start. Okay, so I'll continue the procedure in the next class.